Hello again. So we're going to start on page 6 today of your quote-unquote summer packet. So reviewing over elimination and substitution for solving a system. Generally, we do use elimination. It is generally quicker. But here, what we're looking at is two different conic sections. But you'll notice that the y-squareds, if we add the equations together, will eliminate. So that's what happens here in this first step. So we add these two equations together, the y-squareds cancel. You end up with this quadratic, divide by 2, factor, and then you have your x's. Once you have your x's, you can pick either one of those equations up top, and you're going to plug the 3 in, figure out a y value, plug the 5 in, figure out, you could possibly end up with 2 y values. And then you lay out the points depending on those x and y values. Now, if you do substitution, you actually have to go through this entire process just to get to that step. And then you have to do the rest of this as well. So elimination is generally quicker. So what I'm going to do is let you guys do 23 and 24 because those are fairly straightforward, and I'll just take you through 25. So here again, we have our conic sections. The top guy is actually a hyperbola with the minus y squared. And then the bottom guy is an ellipse. So you have x squared and y squared with different coefficients. So that's an ellipse. But you'll see here again, the y squares, I should say, will cancel if you just add the equations together. So we are going to go through that. So add those, you get 17x squared. Add these together and those cancel. And you want to continue on with like terms. So here I get 340 or minus 340x. Here the y's cancel, which is good. And then in the end here I get what? 1,428 equals 0. Now I did check, and you can divide everything by 17, which is nice because that turns into a much better quadratic to factor. It actually factors. Plus 84 equals 0. So this guy factors into minus 14 and minus 6. So it has to multiply to positive 84 and then combine like terms to negative 20. So here I get x equals 14 and 6. So that's the start of my intersection points. But as you saw in the example, you could have 2 y values for each of these. So we are going to go and substitute back in to figure that out. Now you probably don't have a lot of room right here, so I would just go below this box to do your substitutions. So we'll just start with x equals 14, and you can pick either equation to plug in. I don't know, I'll just pick the second one, doesn't matter. But you just throw everything in there with an x, and you end up with this terrible equation. Now, all of these that are just numbers are going to combine. You are going to get 4y squared plus 64y, and then you end up with 256 equals 0. Okay, this whole thing will divide by 4. So you get y squared plus 16y plus 64. Okay, that factors nicely as well into 8 and 8. So here you get y equals a negative 8. So it ends up there's only one y value for that x value. So one of my intersection points would be at 14, negative 8. Okay, so then you're going to try and plug in 6. When you do that, you actually end up with the exact same quadratic if you did it correctly. So again, y is going to be a negative 8. So, and that's the only y value. So my only two intersections are going to be 14, negative 8, and then 6, negative 8. So that's just a review over the process for elimination. Okay, for doing interval notation, so remember the square bracket means that it's equal to that number. Open bracket means that it's not equal to that number. Whenever you have infinity or negative infinity, you want to use the parentheses. Okay, another way to do it on the graph, you can put the bracket on the graph. But another way to do that is to put a solid dot. That means it's equal to. And then the open circle means that it's not equal to that particular point. So that's another way you can do the graphing piece of that. Okay, and then over here, you're just practicing with those interval notations and the graphing. Domain and range. So it is really critical that you know the basic parent functions for x squared, that's parabola. Square root of x is basically half of a parabola. Sine of x, so you have the sine curve. And then 1 over x. These are all really, really key parent functions. Some other ones might be the x to the third power is also a key one. But I'm going to go through this guy with you. So we're going to do domain and range. So looking at the graph for that is really helpful. So first of all, square root of x is just a curve. It's basically half a parabola to the side. So if you do square root of x plus 3 within the function, that is moving left 3, if you remember that from last year. And then the negative out front basically tells you to flip all of your y values. So if you're doing it in front of the whole function, all of the y values turn opposite signs. So instead of having the graph going this direction, you're going to flip it over the x-axis, and it's actually a graph that looks like that. So there is a rough sketch of what our graph looks like. So domain is part of what x values are applicable or valid. So here, obviously, anything past that negative 3 is not going to be a valid x value. And so, but negative 3 does work. So if I plug in a negative 3 here, I get square root of 0, which is 0. So negative 3 works. And then this will go on forever out to that positive infinity. So range is your y values, and you start from the bottom and go up. So the highest y value is going to be that 0, because this point is at negative 3, 0. So I know it's going to stop at 0. And then where does it start below? Oh, we're going down. Well, this thing, and it doesn't seem like it, but this thing will go on and get lower and lower and lower and lower and lower. As x goes out to infinity, y will actually go out to negative infinity. So you start at negative infinity, and then you're coming up, and then your final y value would be at 0. So this would be your domain and your range. So you want to use that same logic for the other domains and ranges. Okay, inverses. So easy enough. All you do is you switch your x and your y. And I think this is a really good example here. But you switch your x and y. So officially f of x is the y value. And then you have the x, switch places. And then you undo everything to solve for y. And that ends up being your inverse function. So this is a really good just example. You can do that here yourself. Proving that two functions are inverses of each other. So you'd need to do the two compositions, f of g of x, show that that's equal to x, and g of f of x, show that's also equal to x. Again, this is a really nice example that is fairly easy to follow through. So you can try those two. Okay, linear equations. So remember, slope-intercept form, y equals mx plus b. M is your slope, b is your y-intercept. Vertical line is, I like to say, x equals the x-intercept. Horizontal line is y equals the y-intercept. And then point slope form, this really is a super important concept to be able to use in all different contexts. So point slope is y minus a y value that's given to you, and that's equal to the slope times x minus an x value that is given to you as a coordinate point. So we're going to just go through one of these. So which one should we go through? Let's go through number 42. So find the equation of the line passing through the point 2, 8, parallel to this line. So first of all, whenever you have a point here, and then parallel means your slope is going to be the same slope as the parallel line. So if you have a point and a slope, like the name says, you're going to use point slope form. So y minus the y value is equal to slope. Parallel slope is the same. X minus the x value. So this is a perfectly fine answer, to be honest with you. That's the point slope form. A lot of times your algebra teachers like to have you convert that to slope intercept. For that, you will distribute and then eventually add the 8 and then keep it as fractions. Okay, other types of questions here. If you have 2 points, you'll need to figure out the slope using change in y over change in x. So just remember that. And slope formula is huge in calculus. You need to do that for rates of change. It's a huge, huge concept, remembering your change in y over change in x. But you need to figure out the slope and then pick either point to do point slope form. Okay, on the back here, so graphing calculator information. So we did steal this summer packet from another teacher. So he has some, if you're not comfortable, well, this website is not available to you. So that's not going to help you at all. And Texas Instruments no longer offers just an online calculator. I'm sure because everybody's online and they would just use that for free. So I can't really go through all the steps here with you, but I did put a picture of one here, and I'll just go through a couple of things. So y equals, if you remember, that's where you're going to plug in equations that you want to graph. Obviously, the graph button is for graphing. You can use Zoom. You can do Zoom Fit or Zoom Standard. The window button allows you to pick certain max and mins for your x and your y to do the graphing. So all of these top buttons are really, really key to helping you out with these questions. But once you have the y equals in there and you graph it, there is this calc option right here. And in that, it has a menu with tons of stuff in it. You can find a certain value on the graph, like plug in an x and then it'll find your y. You can find zeros. Zeros are the same thing as finding roots. And it's the same thing as finding your x-intercepts. So remember that from previous years. So that's in the calc option. You can also find an intersection in the calc option. So you just hit second trace, and that's where all the calc stuff is. Tables, so we'll go through tables in more detail in the next video. But calc is where you're going to find all of your roots. Okay, and that's what these guys are asking for. So it does give you a little bit of information. So that calc menu, and then you are going to do zeros. What you do have to remember with figuring out zeros is it'll ask for a left bound. So you have to arrow that little blinky cursor to the left side of your zero, hit enter, and then go over to the right side, hit enter, and then hit enter one more time. And then it'll come up with your zero based on that calc function. When you're doing a trig, make sure that you are in Radian mode for any trig equations. Radian mode is you go to the mode button. So again, looking here, you go to this mode button.